Okay, packet 4-4, graphs of polar equations. All right, you guys want the good news or the good news? All right, I'll give you the good news. The good news is there's no pre-lesson. Wait a minute, there's more. Because there's no bad news, there must be more good news. Yes, this is a breather activity. It should be. I know it looks intimidating, and these formulas are like, whoa, that's a lot of information. It's a lot simpler than that. So if we just look at page 131, flip it, this is all you're going to do. You are literally, this is almost like back in elementary school when you'd plot coordinate points, you'd make Christmas trees and stuff during Christmas time. It's almost that easy. So a good calculator is going to be helpful. Let's turn that bad boy on. And here's what you're going to do. You're going to be led by this. I do need you to know that this does not mean triple the degree measure. This means find sine. This is almost like a PEMDAS, where it's like 3 times sine of theta. Find this first. Well, sine of 0, enter, is 0. 0 times 3 is 0. There's my first coordinate. Now I got to plug in 30 degrees for theta. I already know that's 1/2 because I've done 10,000 of them. And 1/2 times 3 is 1.5. Sine of 45, I know what it is, but I'm just going to go like that and then multiply that by 3, and I get 2.1. Now I'm going to go sine of 60 times 3, 2.59. I'm going to call it 2.6. Now watch what happens here. Sine of 90, that's one of our weird ones. It's a 1. And, whoops, I forgot to multiply that by 3. You can see that would have destroyed the pattern. It's slowly going up. And now we're going to go sine of 120 times 3, 2.6. Now it's coming down. Sine of 135, enter, times 3, 2.1. See that? They're starting to repeat themselves. Sine of 150 times 3, 1.5. And then sine of 180 times 3 would be just 0. And now watch what happens here. Sine of 210, enter, times 3, negative 1.5. Sine of 225, enter, times 3, negative 2.12. I'll just call it negative 2.1. Sine of 240 times 3 is 3. Sine of 270, enter, times 3 is negative 3. Did I screw that up? Sine of 270, I don't know why that just bugged me. Okay, so that'd be negative 3. Sine of 300 times 3, negative 2.6. Sine of 315, enter, times 3 is 3. Sine of 330, enter, times 3 is 3. Sine of 360, enter, times 3 is 0. Okay, and now what you're expected to do, and I hope I didn't make a silly mistake in there somewhere, every single one of these are polar coordinates. So the first one is, remember, this is r theta. So my first one is 0, 0. Now I know in a previous lesson I said r can't be 0, but when you're graphing these polar coordinates, it corresponds to that point. Okay. Now how about this one? 1.5, 30. Well, now my spinner is 1.5 right here, and I got to go up 30, which would plunk me right here. And now I go 45. Well, my radius is 2.1, and then I go 45. So I go, my spinner's just a little bit farther than 2 point, or just a little bit further than 2. Then I go 45, which would be right here. And then I'm going to go 2.6, 60. Can you kind of pick up on what's going on here? So 2.6 would be right about here, and then I got to follow that till I get up to 60. And now I keep going. So now I'm going to go 390. So I go out to 3, and I go up to 90. And there's my point. Now, I'm not going to bore you to death by plotting every single one of these, but I want to definitely pick out maybe 2 of these, okay? Because I want you to notice R is negative. And here's where that phrase, man, we're just polar opposites comes from. So negative 3, 270, you have to begin by thinking of it as 3, 270. So I go out to 3. I follow that all the way around till I get to 270. And then that darn negative throws me to the opposite side. So it just repeats that point again. Same thing here. Negative 2.6 comma 300. Ignore that negative. So your radius is 2.6. So it'd be right about here. It says go 300. Now notice every 2 chunks is 30. So to get to 300, I need to go 2.6, go all the way around to, now there's 270, so I need to go 2 more chunks to right here. But then, because of that negative, I need to follow this line, and my brain plays tricks on me. So this is 2, so there it is. And then 2.6 would be right here. And as you can see, this is just going to go like this, and it's going to come back, okay? If you just keep plotting those points, that's what you're going to get. So, for this one, I'm afraid there was a misprint, so we're just going to wing it and say this is R equals negative 2 cosine theta plus 1, and hopefully we corrected the typo. So what we're going to do is just do a couple of these and plot them. Now, I'm not going to finish this for you because I think you're getting the gist. As you can see, the potential for these drawings are off the charts. And I'm going to go out on a limb and say these start applying to the real world. To me, that looks like a little shell. What else looks, well, you got a little flower here. I mean, interesting. So let's go on to this. Again, we're just plotting in, just to get started. This is our theta, this is our R. I don't know if I ever said that up here, but I should have. This is our theta, this is our R. And so just plug it in, and we'll forget about the graph for a little bit. So we got cosine of 0, and then we're going to multiply that by, so cosine of 0 is 1. Times negative 2 is negative 2, plus 1 gives us our negative 1. Now you could do this mental if you wanted to, but I'm just showing you every little step. So now I got to take cosine of 30. Then I got to multiply that by negative 2. And then I got to add 1, negative 0.7. So that's negative 0.7. And let's just do one more of those. So I'm going to go cosine of 45 times negative 2, and then plus 1, negative 0.4. Okay, so, and I just keep going and going and going and going until I'm done. And then when I'm done, it will form a nice little interesting, unique shape. Now, I did wing it by saying, hey, let's just stick an R in front of this. So I'm not sure what's going to happen. But really, this is an exercise of just plotting your polar coordinates, especially if this is negative. Now, watch this one. So this is negative 1, 0. What really means is, it means start here. So it's like, okay, there it is, 1, 0. But then what does that negative mean? It means go to the opposite side. And that's where it is. How about this guy? Well, that's going to be negative 0.7 comma 30. Again, your brain needs to think this to get started. So we go almost to 1, rotate it to 30, And then we follow that across the other side, and there it is, that point right there. So I'll call this point A, and I'll label that A. I'll call this point B. You can label that B, and we'll do one more. So this guy, negative 0.4, comma, 45 degrees. So again, you got to think like this. Find this first. So that means go about halfway to 1, which is right about here, maybe a little less. Then go to 45, which would be right here. And then you got to go to the other side to be right here. See, it's kind of looping back around. And you just keep plugging stuff in and get all your points, and then you're going to have a really cool graph there. But I think you get the idea. And you can see your homework has 3 of them. There you go. I'll tell you what. You're going to have to remind me of this, but when you do this one and this one, we'll call it good. If you actually finish this one, I'll give you some bonus on your homework points. Does that sound like a good plan? Because it does get a little bit overkill-ish. Once you get the gist, you get the gist. All right. Good luck.